properties of inner product. If we have an inner product between x and y, that is given as in continuous time minus infinity plus infinity x conjugate t yt dt, and in discrete time summation so both continuous time and discrete time representations. And some of the properties is the energy property. So the inner product of a signal with itself is basically this, which is basically the energy of the signal. First property. Second is the inner product between two signals is 0. That means the signals are orthogonal to each other. Third property. The square distance norm is given by this square norm of x plus square norm of y minus 2 times x transpose y. This is basically the inner product. Also, statistically speaking, the inner product represents a similarity between two vectors or similarity between two signals or whatever. Statistically, that means we are measuring a correlation between the two vectors. So inner product is a measure of correlation. So inner product is basically a correlation. So these are some of the properties which will be handy later on in the entire signal processing theory for inner product. Now for the signal processing, based on this inner product idea, we have some sort of basis set on which we expand the signal. So the analysis formula for signal processing is in general analysis. When we do a basis expansion over the inner product and we find out the coefficients, that is xk. So xk is equal to the expansion coefficients. This is the inner product between the basis set uk and x normalized by uk square. This is the analysis formula, and when we want to synthesize a signal based on the basis set, we basically weight the basis set with xk. So by weighting of the basis set with xk, we synthesize the inner product. So that gives us x. So this is a synthesis formula. Now some typical basis sets in signal processing is a Fourier basis. Now what is a Fourier basis? A Fourier basis has uk is equal to, in the continuous time, e to the power j 2 pi ft, and in the discrete time the same uk should be is equal to e to the power j 2 pi by n kn. So this is the Fourier basis in continuous time and discrete time both. Now we move forward to the idea of Fourier transformation with the use of this Fourier basis consecutively.